Alright, welcome back to Christoph Desk. Alright, so this is sample survey, and then we are making videos on series of lectures that was or that is being given to or that is offered in the university, KNUST, and then the subject or the course is sample survey. Alright, sample survey or sampling techniques, right? Sample survey and what methods. Okay, so that's the name of the course. I think this is the first course in it, right? So for you to have access to more of my videos, make sure you subscribe to the channel, hit the like button, all right, and then just comment. Okay, so with your comment we can do better videos so that you can have a very good access to all the videos and then understand the concept very well, right? So in the previous videos we've talked about the various errors that will occur when you are trying to do a sample survey. All right, yeah, just the fact that you are doing a survey, there is that error that you are going to encounter. And then we mentioned that there are two errors. We said that there are two errors that you can come up or you can get two errors, right? And we said the first one is a sampling error. It's a sampling error. And then the second one is a non-sampling error, right? A non-sampling error. So remember we said that these errors happen because of the fact that you are taking a sample, right? You are not using everybody in the population or you are not involving everybody in the population in the sample or in the survey, right? So it means you are not taking the variables from everybody in the population, but you are just picking a portion of them and try to take information from them, right? And then you do inferential statistics. So the fact that you are taking a sample brings about the sampling error. And then the non-sampling error, will say that it's just any error that can happen, right? Not necessary sampling. So when you are doing any sample or trying to do any survey and then there is some error which is not because of the sample you took, right, then that error is categorized as a non-sampling error. So take note of that. So now we discuss the types of sampling techniques, and we said that there are two basic types. All right, two basic. We have the probability sampling or random sampling, and then the non-probability sampling or the non-random sampling. All right, so in this course we are trying to look at the probability sampling or the random sampling. Okay, remember we said that for random sampling, if you are doing random sampling and then this is your population, if this is your population, you are doing random sampling, this is your population, what happens is that every element in the population has some known probability of being part of the sample, right? So every element in there has some known probability of being part of the sample or being selected to take part in the survey. All right, so a typical example is you go to a community and you want to set up a business, isn't it? So you want to know the average salary of that community, people living in that community. All right, so you try to know the framework, or you just know your list of everyone who is working in the community, the workers in the community. So it happened that knowing all of them will constitute your population, isn't it? So for probability sampling, it tells you that everybody in the population has some known probability of being selected. So there is that tendency that somebody gets selected. All right, so let's introduce this. All right, So we are trying to go through the probability sampling. So that's what we're trying to do. Sample surveys cost time and money and are sometimes almost impossible to conduct. Alright. Suppose we want to obtain an estimate of the proportion of households in Kumasi who plan to purchase new television sets using a random sample of 3,000 households. There are a number of problems which would be encountered in collection of these data. Alright, so this is a typical example. So sample surveys, even though we said that conducting census, that is putting everybody in your frame or taking data from everybody, is very difficult to do that, time consuming. But when you also take a sample, it doesn't eliminate the cost, or it doesn't eliminate the cost at all, but just that there is that reduction in cost. So sample surveys also cost, right? Also cost. So using, say, random numbers table to select, we would list all the households in Kumasi. Obtaining such a list from some obstacles will be encountered. So you want to know all the households, yes, in Kumasi, you would have to be able to get everybody on board before you come and take a sample. That's going to be very difficult and time consuming. If you don't have the resources, you can't even do that. But there are some sample surveys that doesn't look very difficult. It depends on your field. It depends on where you are working. So the sample design categorized into, talked about that, non-probability sampling and then probability sampling. And then we discussed the non-probability sampling, some of them. Alright, so these are the non-probability sampling, judgmental, Kupta, and then the random sampling or probability sampling. We talked about some of them. Alright, so the first probability sampling or random sampling technique we are trying to talk about is a simple random sampling. Alright, it's a simple random sampling. We are trying to talk about the simple random sampling. This is what we are trying to talk about. Remember that simple random sampling is under probability sampling, or it's under random sampling. Right? So simple random sampling is under random sampling or probability sampling. Right? So this is what we will discuss henceforth. So we said that this method is designed to select a sample from a population of size n in such a way that all the possible values or samples of n have equal chances of being selected. Equal chances of being selected. So here what we are saying is, okay, it's a probability sampling. There is some known probability, right? What we are doing is a probability sampling. We know that we are doing a probability sampling, and we said that there is a known probability. We said that there is a known probability. We said that there is a known probability. So now, what is this known probability? That's the question. What is this known probability? So in simple random sampling, we are saying that these known probabilities are equal. All right. These known probabilities are equal. So here we are giving you information about the known probability. So for simple random sampling, we said that probability which is known, they are equal among the various samples. So here there are two definitions. Alright, so this method is designed to select sample from a population of size n such a way that all possible samples of size n, alright, have equal chance of being selected. Alright, this implies that each item or element, look, that's what I'm saying, there are two definitions. Each item or element in the population is equally included in the sample. So what this one also means is that the definition is saying that all the possible samples that can come up, they have equal chance of being selected. All right, and then it also goes further to say that here, if that is true, then we can say that every element in there has also equal chance of being part of the sample. All right, so that's a basic definition of simple random sampling. Right, so typically if this is your population and then you have this marks 5, 6, 4, 3. All right, so you want to know all the possible samples. You do 5 and 6, you can get 5 and 4, you can get 5 and 3, you can get 6 and 3, you can get 6 and 4, and you can finally get 4 and 3, isn't it? So I think we have 6 of them, or it's not 6. 1, 2, 3, 4, 5, 6. Can we get another? 3, 6. We have 3, 6. I think that's all. So these are the possible samples we can get, and this can be found using the formula, I think 2 raised to the power capital N. Okay, yeah, 2 raised to the power capital N. So this formula will give you the possible samples you can get. 2 raised to the power capital N. So if there are 4 elements here, then you have 2 raised to the power 4, isn't it? So 2 raised to the power 4 is like 2 times 2 times 2. Is that it? I'm trying to times 2. So this is 4, this is 8 and 16. I think you get that if you are doing it with replacement. Okay, so it means you can turn, when you turn them around to, it also affect everything. All right, yeah. So basically that's the definition you need to go through this course. Okay, all right, so make sure you subscribe to the channel. We'll continue and ratify every mistake that was committed maybe along the way, so that you can follow the thing successfully. So make sure you don't mix anything up. All right, make sure you follow, you subscribe to the channel and get updates.